Assalamualaikum and good day everyone. Today we'll continue our chapter 5 which is 3. So this is our last subtopic on the chapter 5, 5.5 minimum spanning tree. At the end of the class you should be able to find minimum spanning tree using Prim algorithm and the Kruskal algorithm. A minimum spanning tree in a connected weighted graph is a spanning tree that has the smallest possible sum of weights of its edges. There are two algorithms that can be used to find the minimum spanning tree, which are Prim algorithm and the Kruskal algorithm. Okay, let's see for the Prim algorithm. Firstly, we need to choose an edge with the least weight and include it in the spanning tree. Next is we need to select an edge of the least weight that is incident with a vertex of an edge in the T. If does not create a cycle, then include it in the T. Otherwise, discharge it. Repeat the step 3 and 4 until T contain n-1 edges. There may be more than one minimum spanning tree for a given connected weighted simple graph. If there are two edges have the smallest weight, so we have to choose either one. So let's see the example for the Prim algorithm. So firstly we need to take note that in the Prim algorithm we need to choose an edge with the least weight. For the second one is we need to choose second edges with the select an edge of the least weight that is incident with the chosen vertex. So we cannot create a cycle on the Prim algorithm. So let's see for the figure 5.5.5. So this is the example, the weighted simple graph. So to solve the Prim algorithm, we use the table to show step by step how the Prim algorithm to show step by step in the Prim algorithm. Alright, so the first choice is we need to choose an edge with the least weight. So in the figure 5.5.5, we see that the least weight here is 1 at the edge BD and the edge CE. So we can choose either one, whether we want to choose BD or the edge CE. So let's say I choose the edge BD as our first choice. So we write down the weight. So the weight is 1. So we'll draw the spanning tree of the BD. So for the second choice, we need to consider for the second choice, we need to choose the second edges with this, by the selecting an edges of the least weight that is incident with the chosen vertex. So we have here the chosen vertex is B and D. So we need to see the incident with the B and D. So we see here B is incident with the C, A and also D. D is incident with the A, E and F. So we need to see the incident here and choose the least weight from the incident. So we can see here the least weight is 2. We have 3 edges that have the least weight 2, so we can choose either one. So let's say I choose B to C. So for our second choice, I choose for the B to C with the weight 2. So we draw the our spanning tree here. So so this is not create a cycle, so it's okay. So for the next edges that we want to choose, we also need to consider for the incident with the C also, with the vertex C also. So we see that vertex C has the incident with the vertex A, E and F. So for the previous incident, we also need to consider for the previous incident. So we see for all the incident here, the least weight here is 1, which is C to E. Okay, so we choose for the C to E since it's the least weight that have in the incident. Alright, so for the third one, we choose the CE with the weight 1, so we draw the spanning tree. So we already used the E here, so we need to consider the incident with the vertex E also. So for all the incident here, we can see the least which is 2 at the edge ED and at the edge AB. So we can choose either one, ED or the BA here. If you want to choose ED here, we can see if we choose ED here, the edge ED here, it can form a cycle. So we cannot choose the wedge ED here, since we cannot create a cycle in the Prim algorithm. So the next least wedge is B to A that have the wedge 2. So we just, for our fourth choice is we choose the B to A that have the wedge 2. So we just draw our spanning tree. So we can see that we left one more vertex that need to connect. So so we can see here our next least wedge is the 3. So we can see here A to C and D to F have the wedge 3, but we cannot choose the A to C since it can form a cycle. So we choose the D to F, so it's do not form a cycle here. So we can choose for the D to F. So for our fifth choice, we choose D to F with the wedge 3, and we can see all the vertices have been used in the spanning tree. Alright, so our spanning tree contain all the vertices. So we are done with the Prim algorithm since our spanning tree already contain all the vertices. Alright, so this is our solution. We need to total all the wedge that in the table. So we have the total wedge is equal to 9. So this is the shape of our spanning tree. If you choose a different choice of the edges, you can have different shape of the spanning tree, but you can still have the same total wedge, which is 9. Alright. So let's see for the Kruskal algorithm. In the Kruskal algorithm, we need to arrange the edge in the increasing order. So next we choose the minimum wedge and include it in the spanning tree. Then add edge on the least wedge to T. So if it does not create a cycle with the edge in T, then it include in T. Otherwise, discharge it. So it's still the same. There may be more than one spanning tree for a given connected wedged simple graph. If there are two edges with the smallest wedge, choose either one. So let's see for the example in the Kruskal algorithm. We use the same table, choice, edge, wedge, and the spanning tree to show the step by step on the Kruskal algorithm. So not for the Kruskal algorithm. Firstly, we need to choose an edge with the least wedge. So by increasing order, we choose another edge. Alright. So you also cannot create a cycle. Okay. So we need to avoid the cycle. So we use the same figure as the Prim algorithm, but the step in the table is different. Okay. So let's see. In the figure 5.5.5, we need to choose the least wedge here is we have 1. So BD here and the CE have 1. Have the wedge 1. So you can choose either one. So let's say I choose the BD here with the wedge 1. So we already done with the BD here. So the next least wedge is also 1 at the CE here. So you can see if we choose CE, it cannot create a cycle, then we can choose the CE. So for our second choice is we choose the CE, since it's also the least wedge here. So we choose the CE, so we draw our spanning tree. So for the second one is least edges is 2. So we can see the edges that have the least 2 is AB, BC and DE. So we can choose either one. So let's say I choose BC first. So we draw BC here, our spanning tree. So for our fourth, we left the AB or the DE at the wedge 2. So if I want to choose the ED here, it can form a cycle. So we cannot choose the ED since it can form a cycle, since we want to avoid to create a cycle. So we choose the HAB here. So for our fourth choice is AB. So we draw our spanning tree and we write down the wedge. So for the next step, we see the next least wedge after 2 is 3. So 3, we see we have the 3 here at the edges AC and edges DF. So if we choose edges AC, we can see that it can form a cycle here, so we cannot choose an edges of AC. So we can choose edges DF. So we see in our spanning tree, if we choose edges DF, then it does not form a cycle, so we can choose the edges DF here. So we just draw our spanning tree DF and we choose edges DF with the wedge 3. So we can see in our spanning tree that all the edges here, all the vertices has been in the spanning tree. So our spanning tree contains all the vertices. And what we need to do next is we need to total all the wedge in the table. So the total wedge is 9 and the solution is the solution of the spanning tree is like this. So for the Kruskal, it's also the same. If you choose different edges at the start or different edges at the middle, so you can have different shape of the spanning tree. You can have different shape of the spanning tree, but the total wedge is still the same with the others. Okay. So this is another example for the Prim's algorithm and the Kruskal algorithm, so you can see and do by your own. So this is the example solution of the Prim algorithm and the Kruskal algorithm. Alright, so this is exercise for the Prim algorithm and the Kruskal algorithm. So that's end of our chapter 5. Thank you everyone. Have a nice day.